Today we are going to start to look at the concept of area. Now, area is the measurement of the inside space of a two-dimensional figure. And so we're only going to focus today on parallelograms and trapezoids. So let's start with our parallelograms. So to begin with, we need some measurements, some dimensions we can look at. And on our parallelogram, our bottom measurement is called our base. Now we have two different kinds of heights. The outside slant is called the slant height, and the inside that goes from right where the corner is down, that's called the height. What we use for our area calculation, it's always that inside height. Never use the slant height. That is not our height that we use. Now, the formula for finding the area of a parallelogram is exactly the same formula for finding area of a rectangle. It's base times height. Why is that? Well, because we can take this parallelogram and we can cut off this side and we can pull it over and we can attach it there. And you can see right there, that parallelogram instantly becomes a rectangle. That's why the formulas are the same. Now, when we go to actually solve these, they can leave out any information they want. So in this first example, they're going to give me my base, they're going to give me my height. I need to find my area. Well, sometimes my height isn't going to be a whole number. It's going to be a fraction. Don't let that concern you. So I always start off by writing what my formula is. It helps me remember what to fill in. So my formula for area of a parallelogram is base times height. My base here is 10. My height here is 10/4. Now, when I go to multiply, if it's a fraction, remember it's numerator times numerator, denominator times denominator. It doesn't look like I have a denominator there, so I'm just going to put that number over 1. And if I do 10 times 10, that's 100. 1 times 4 is 4, and that's an easy division problem to do. 100 divided by 4 is 25. Now, notice our unit of measure. We say meters squared. The reason why we say that is because area is made up of two dimensions. My dimension of my base and my dimension of my height. So every time we're using an area answer or getting an area answer, we have to use whatever the unit of measure is squared. Now sometimes they're going to give me the area, but they're going to either leave off the base or the height. So that's example 2 here. In example 2, I don't have any idea what the base is, but I do know the height is 45 meters. And they did tell me the area was 2025. Well, this is where we depend on our algebraic equation, because I can substitute 2025 in for the A or area. I don't know my B or my base, so I'm just going to leave that as B. And I know my height is 45. Well, that just creates my equation. Now, I like to have my coefficient before the variable, so I'm going to rewrite that as 2025 equals 45B. Now it's just a one-step equation. I need to get B by itself, so to get rid of this times 45, I'm going to divide both sides by 45. In the end, I get B equals 45 meters. Now, notice I'm not putting meters squared because this is just one dimension. I'm just calculating the measurement of my base. So that's the difference. Area has to have units squared, but if you're looking at just your base or your height, it's just going to simply be your units. Now, the more interesting polygon is the trapezoid, and I think most of you have never calculated area of a trapezoid. So if we take a look at the trapezoid actually has two bases. It has a base on top, which is the shorter base, and it has a base on bottom. Now, it follows the parallelogram in that it does have a slant height, which we won't use. That's why I didn't even put it there. And it has just the regular height, which is what we use. Now, the formula looks like a monster. If we look at this, the area of a trapezoid is base 1 plus base 2 multiplied by the height divided by 2. So I want to break down why it looks like that. If I take this trapezoid and I put it right here, and then I take a second one and I flip it over, all of a sudden my base 2 and my base 1, because it was flipped, become one line. And I still have my height, but remember, I don't want the 2 trapezoids, I only want the 1. So you can see right here, to get this base, this big long base with the 2 of them, I'm going to take my base 1 and add it to my base 2. I'm going to multiply by my height, but in order to get rid of this second trapezoid, I divide by 2 because they are exactly the same size. That's how the formula actually works. Now, to actually use it, all you have to do is remember the formula and just substitute or plug in. So again, sometimes they want me to find my area. And if I want to find my area of this, they have to give me my base 1 and my base 2 and my height. I can only have one unknown. So if they do this, I first start off with my formula, because I always do. Now, sometimes I just abbreviate. So A stands for area, B1 is my base 1, B2 is my base 2, H is my height. So my B1, remember that's the shorter one, is my 9 feet. My B2, which is my longer one, is my 16 feet. My height is my 12. And I just fill it in, I'm not calculating. Now we have to follow order of operations. So I have to solve what's on top first, and I'm going to do this addition first because that actually has an operation before I do that multiplication. So 9 plus 16 is 25. I still have my times 12 divided by 2 because I only solve one thing per line. Now I do 25 times 12, which is 300. I only solve one thing per line. As soon as everything on top of that division bar is calculated, then you go ahead and do your divided by 2. So I know again my area is 150 feet squared because it's a two-dimensional figure with that. Okay, but they're going to get a little rough here. Sometimes they leave out your bases or your heights. So if that's the case, this is a fun one. They're going to give me my area. They're going to say this trapezoid has an area of 1,800 feet squared. I don't know my base 1, which is my shorter one. Even though it's tipped over, it's still the shorter one on the bottom, so that's my base 1. I do know my base 2, which is 50, and I know my height is 48. So I substitute the values in, and instantly what you should be seeing is distributive property. You're not expecting it here, but you have to spot it whenever it's there. So I have to do my distributive property because that's my order of operations. So I take my outside number times my first, which is 48 times B1, I just say 48B. And I take my outside number times my second, which is 48 times 50. I still have divided by 2. So now I solve it. Well, 48 times 50 is 2,400. I still have my 48B, and I divide it by 2. All right, well, this is where I like to do my division first because this divide by 2 can go here, and it also goes here. So I'm going to take 48 divided by 2, I get 24B. I'm trying to get rid of that divided by 2. I'm going to take my 2,400 divided by 2, and I get 1,200. Now I got rid of that fraction. So my equation becomes 1,800 equals 24B plus 1,200. Now I have my two-step equation. I'm going to get rid of this 1,200 by subtraction. I'm left with 600 equals 24B. I'm going to divide both sides by 24, and that base 1, which is the shorter length, is 25 feet. I don't use units squared because it's just a one-dimensional measurement. So this would be 25 feet. My base 2 would be 50 feet, and my height would be 48 feet if I'm going to have an area of 1,800. In these equations, they can leave anything out for our dimensions. So we have to read them carefully, just set up our equations and solve like we always have done in the past. So have fun calculating area for parallelograms and trapezoids. I know you'll do well.